Good afternoon, everyone, and welcome to another session on GATE Physics problem solving sessions. Um for those of you who are joining for the first time, I would be providing some links in the chat box. So these links are important links for this course or these sessions. So the first one is the YouTube channel for this course, and you can go ahead and subscribe to that YouTube channel. So you can find the recordings of all the previous sessions as well as some other problem solving videos on that channel. And the other link is a Google Drive folder link, which has all these lecture notes that I would be uploading over there. And finally, there is this Discord server link. So we have a Discord server where you can join and you can post your questions, and you will receive feedback from me as well as from your uh, friends. So let us get started with the sessions now. So this week we would be focusing on electromagnetic theory, and as always we would start first with a few general aptitude questions, followed by some electromagnetic theory questions. So let us get started with the first question. So the first question over here says that a set of four parallel lines intersect with another set of five parallel lines. So how many parallelograms are formed? So let us first draw these parallel lines. So first we have a set of four parallel lines. So let me draw four parallel lines as parallel as I can possibly draw them. So, and another set of five parallel lines. So at a different angle. So five of these parallel lines. So we need to find out the number of parallelograms formed. So a parallelogram is formed by four sides. So two parallel lines in one direction and two parallel lines in another direction. So these four lines would form a parallelogram. So number of such parallelograms this would be. So we are first selecting uh, two lines from the set of 5. So 5C2 into 4C2. So these two parallel lines from one direction and two parallel lines from the other direction. So this would be 5C2 times 4C2. That gives you 5 factorial by 2 factorial, 3 factorial, 4 factorial by 2 factorial, 2 factorial. So this comes out to be equal to 60. So the answer is C, 60. Moving on to the next question. An automobile travels from city A to city B and returns to city A by the same route. The speed of the vehicle during the onward and return journeys were constant at 60 kilometers per hour and 90 kilometers per hour respectively. What is the average speed in kilometers per hour for the entire journey? So very simple question. So let the distance between A and B be x kilometers, then the average speed is equal to total distance over total time. So total distance would be 2 times x kilometers because it is a to and fro journey, and time would be x divided by 60 plus x divided by 90 because the onward journey takes onward journey is with the speed 60 kilometers per hour, and the return journey is with the speed 90 kilometers per hour. So this is 2x divided by x by 60 plus x by 90 kilometers per hour. Sorry, x gets cancelled, so that is 2. So and this comes out to be equal to 72 kilometers per hour. Option A. So let's move on. The third question says the number of 3-digit numbers such that the digit 1 is never to the immediate right of 2 is, so we need to find out 3-digit numbers according to the given constraint. So let us represent the 3-digit numbers. So first let us look at number of ways in which 1 is to the immediate right of 2. So let's say we have 2, then we have 1 over here, and the other case could be that we have 2 here and 1 here. So in this, there can be 10 ways. Over here, there can be 9 ways. Why? Because this 10 ways would be from 0 to 9 digits, and these 9 ways would be from 1 to 9. 0 cannot be there because we want a 3-digit number. So these are 19 ways, and total 3-digit numbers will be total number of 3-digit numbers so there are 10 ways here, 10 ways here, and 9 ways here. So this makes it 9 into 10 into 10, that is 900. So number of 3-digit numbers such that 1 is never to the immediate right of 2 would be total 3-digit numbers minus the number of ways in which 1 is to the right of 2. So that is 900 minus 19, which is 881. 1. Option C. Let's move ahead. So 1200 men and 500 women can build a bridge in 2 weeks. 900 men and 250 women will take 3 weeks to build the same bridge. How many men will be needed to build the bridge in 1 week? So let us start. 1200 men plus 500 women. This means that the bridge will be made in 2 weeks. So bridge in 2 weeks. And for 1 week, this would imply 2400 men, means into 2 we need to do, plus 1000 women. This would be bridge in 1 week. Then the next condition that we are given is that 900 men plus 250 women. This means that bridge is built in 3 weeks. So for 1 week, we need to do into 3, sorry, not into 2, into 3 this time. This would mean that the bridge is built in 1 week. So from here, what we get is that 2400 men plus 1000 women is equivalent to 2700 men plus 750 women. Because in both these configurations, you can build the bridge in 1 week. So this implies we can rearrange. So this means that 250 women is equivalent to 300 men. That means one woman is equal to 6 by 5 man. So the amount of time, this is in terms of that, the amount of time that it would take to build the bridge. So to build the bridge in 1 week, what do we need? We need 2400 men plus 1000 women. So this is equivalent to 2400 men plus 1000 into 6 by 5 men, because one woman is equivalent to 6 by 5 man. So this makes it a total of 3600 men. Next question. This is a comprehension based question. So the passage reads as follows. If you are looking for a history of India or for an account of the rise and fall of the British Raj, or for the reason of the cleaving of subcontinent into two mutually antagonistic parts and the effects this mutilation will have in the respective sections and ultimately on Asia, you will not find it in these pages. For though I have spent a lifetime in the country, I lived too near the seat of events and was too intimately associated with the actors to get the perspective needed for the impartial recording of these matters. So the question says, which of the following statements best reflects the author's opinion? And the options are: An intimate association does not allow for the necessary perspective. Matters are recorded with an impartial perspective. An intimate association offers an impartial perspective, and actors are typically associated with the impartial recording of the matters. Now, in this passage, basically, this author seems to be a historian who has actually uh, who seems to have actually witnessed the freedom struggle and the partition and the British Raj. And the author is basically trying to say that because he or she was too closely associated with all these events and with all these people, so even though he has like a first hand, he or she has a first hand account of all these events, it would be probably difficult to provide an impartial opinion. The opinion could be biased based on his or her personal experiences. So, the correct option over here would be A. An intimate association does not allow for the necessary perspective. Next question. This is the last question in the general aptitude section. So, 500 students are taking one or more courses out of chemistry, physics, and mathematics. Registration records indicate course and enrollment as follows. So, we are given the number of students who have taken chemistry, physics, mathematics, and the number of students who have taken two or out of these three subjects. Then we are supposed to find out how many students are taking all three subjects. So let us start. Number of students taking chemistry is 329. Number of students taking mathematics So we are just writing down all the information that is provided to us in the question. So personally, if I had the option, I would take this last combination of mathematics and physics because these are the subjects that I like. But it seems that the least number of people have taken this combination, although this is my favorite combination. So now we need to find out number of students taking all three subjects. And total number of students we are given is 500. Now, from the properties of sets and cardinality, we have the following result. So now we will just put in all the values. So this is 53. This completes the section on general aptitude, and now we will move towards electromagnetic theory. So the first question in electromagnetic theory is as follows. In a set of n successive polarizers, the mth polarizer makes an angle m pi by 2n with the vertical. A vertically polarized light of intensity I naught is incident on two such sets with n equal to n1 and n equal to n2, where n2 is greater than n1. Let the intensity of light beams coming out be IN1 and IN2 respectively. Which of the following statements is correct about the two outgoing beams? So let us start solving. So after n polarizers, the angle made would be n pi over 2n, which is equal to pi by 2, and this is angle made with the first with the input. Angle made with the input light beam. So this means that so this pi by 2 angle is being made. So this is orthogonal polarization. Orthogonal polarization to the incident. And the incident is vertical. Incident polarization is vertical. So orthogonal to that would be horizontal, which is the output polarization. So either of option C or D would be the correct option. So now we need to look at the intensities. For that, we will make use of what is known as Malus law. So according to Malus law, intensity at the output of a polarizer is given as follows. I naught cos squared theta, where I naught is the intensity of the incoming polarized beam, and theta is the angle between input polarization and pass axis of polarizer. So pass axis of polarizer determines the uh, output polarization, output polarization direction. So when we have N1 polarizers, the intensity would be I naught cos squared pi over 2n1, because each successive polarizer makes an angle pi over 2n. This raised to the power n1. Now why? Because we have n1 polarizers, and each makes an angle pi over 2n1 with the previous. Similarly, we have, so this is in1, now we have in2. Why? Because now we have n2 polarizers, each making angle pi over 2n2 with the previous. For n2 greater than n1, this is the condition that we are given. We have pi over, so n2 is greater than n1. This implies that pi over 2n2 will be less than pi over 2n1. This means that cosine of pi over 2n2 would be greater than cosine of pi over 2n1, because cosine for a smaller angle has a greater value than cosine of a larger angle. So this implies that first let us multiply with a constant, so that is I naught. Now we get before this we can do another step, that is the following. This is because cosine of pi over 2 and 2 is greater than cosine of pi over 2 and 1. So if we multiply that again, so the inequality sign remains intact. Then we will take power Uh, Now, since N2 is greater than N1, that would mean the following. Raised to the power N2. This will also be greater than the following. Since N2 is greater than N1. And that means that I of N2 is greater than I of N1. So the correct option is option C, that IN2 is greater than IN1 and the polarization is horizontal. The next question is, the electric field of an electromagnetic wave is given by E is equal to 3 sine kz minus omega t x cap plus 4 cos kz minus omega t y cap. The wave is, and we need to find out the polarization of the wave. So let us start. So without loss of generality, let us consider the z equal to 0 plane. So at z equal to 0, our electric field is given as as follows. Uh, this term is Ex component, this term is Ey component. So what we get, you can easily see, is that Ex squared divided by 9 plus Ey squared divided by 16. This is nothing but sine squared omega t plus cos squared omega t, which is equal to 1. And this is equation of ellipse. So that means the light is elliptically polarized. Now we need to check the handedness of the polarization. So for that, let us consider omega t equal to 0. Then we have Ex equal to 0, Ey equal to 4. Then omega t equal to pi by 2. So Ex equal to minus 3, Ey equal to 0, omega t equal to pi gives Ex equal to 0, Ey equal to minus 4, and omega t equal to 3 pi by 2. We have Ex equal to 3, Ey equal to 0. So let me just draw it out over here. So this is x axis, this is y axis, and at omega t equal to 0, we are at this point, and at omega t equal to pi by 2, we are at this point. Then we go to this point and finally to this point. So the direction is like this, which is counterclockwise direction. and the direction of propagation, because of these terms over here, the electric field of the wave, or the rather the electromagnetic wave, is traveling in positive z direction. So it is counterclockwise when seen traveling towards the observer. Why? Because the z axis is coming out of the page, that is towards me, towards the observer. So the correct option is option D, elliptically polarized in counterclockwise direction when seen traveling towards the observer. So the next question that we have is on vector potential. The question states that the vector potential inside a long solenoid with n turns per unit length and carrying current I, written in cylindrical coordinates, is given as follows. Vector potential is mu naught n I s over 2 in the phi cap direction. If the term mu naught n I s by 2 times alpha cos phi cap direction plus beta sin phi s cap direction, where alpha and beta are non-zero, is added to the previous vector potential, the magnitude of the magnetic field remains same if we need to, and then we need to find out the conditions between alpha and beta such that the magnitude of the such that the magnetic field remains the same. So curl here, magnetic field is given as curl of the vector potential, and curl in cylindrical coordinates is given as follows. So this is curl in cylindrical coordinates, and this is equal to the magnetic field. So curl of A is magnetic field. Now when we have A as follows, then our magnetic field is given as follows. So this is nothing but mu naught n I in the z cap direction. Now we have a new vector potential, which is the old vector potential plus an additional term. So this would give us a magnetic field, a new magnetic field as follows. So this gives us a magnetic field in the z cap direction. So for the new magnetic field to be equal to the old magnetic field, we get the following condition. And since cosine phi would not be 0 always, so this gives us that alpha minus beta by 2 is equal to 0. So alpha is nothing but beta over 2. So the correct option is option D, alpha equal to beta by 2. This means that if alpha is equal to beta by 2, then the new magnetic field would be same as the old magnetic field, even though we have added an extra term in the magnetic vector potential. So this solves this question, and we can move ahead to the next part. Sorry, the next question. The next question says a solid cylinder of radius r has total charge capital Q distributed uniformly over its volume. It is rotating about its axis with angular speed omega. The magnitude of the total magnetic moment of the cylinder is, we need to find out. So before proceeding to finding out the magnetic moment of the cylinder, let us first start with the disk. And let us try and find out the magnetic moment of the disk. So consider a disk of radius r and surface charge density sigma. So we will first find out for this disk. So here is the disk. And it is rotating about the z-axis with speed omega. And we have an element in the disk, element in the form of a ring. So this is radius r, radius of the element is r, small r, and its thickness is dr. So we have this element which is ring of radius small r and thickness dr. Time period is 2 pi over omega. The current in this element is dq over t. dq is nothing but sigma dA, and dA is nothing but 2 pi r dr. And the magnetic moment of the element would then be current times area. So di times pi r squared. So the total magnetic moment of the disk would be integrating the elemental magnetic moment of the ring. This is because total charge is charge density times area, which is sigma times pi r squared. Now let us come back to our original question of the cylinder. So let's consider a cylinder of length L. So we have this cylinder, and in this cylinder we will select an element which is a disk. So this is my element and its length is dz. So this is the element that I have, which is a disk of thickness dz. So and time period is again 2 pi over omega. This cylinder is rotating about the z axis. Which coincides with the axis of the cylinder. And the magnetic moment of the element is from here. This would be dq r squared omega over 4. And dq is nothing but rho dV. And dV is nothing but pi r squared dz. dV is the elemental volume. So the total magnetic moment would be by integrating elemental magnetic moments across the length of the cylinder. Now rho is charge over volume and volume is pi r squared L. So this L cancels out, giving us q r squared omega over 4. So option C is the correct option. Now next question. The electric field of an electromagnetic wave in vacuum is given by E is equal to E naught cos 3y plus 4z minus 1.5 into 10 to the power 9t in the x cap direction. The wave is reflected from the z equal to 0 surface. If the pressure exerted on the surface is alpha epsilon naught E naught squared, then the value of alpha is, we need to find out. So electric field is given as follows. So from here we see that omega is 1.5 into 10 to the power 9 radians per second. K, that is the direction of the wave vector, is as follows. So we have ky equal to 3, kz equal to 4. So tan theta is ky over kz, which is 3 over 4. And this gives that cos theta is equal to 4 over 5. Why? Because we have this 3, 4, 5 triangle. So tan theta, this is theta, tan theta is 3 by 4. And then the hypotenuse would be square root of 3 squared plus 4 squared, that is 5. Now pressure is given as follows. And cosine of theta is 4 over 5. So we have 4 by 5 epsilon naught E naught squared. And we are given that pressure is alpha epsilon naught E naught squared. So by comparing this, we get that alpha is equal to 4 over 5, which is nothing but 0.8. And finally, we have the last question of today's session. An infinitely long, thin cylindrical shell has its axis coinciding with the z-axis. It carries a surface charge density sigma naught cos phi, where phi is the polar coordinate and sigma naught is a constant. The magnitude of electric field inside the cylinder is, we need to find out. Now, the electric field due to an infinitely long wire or line charge is given as follows, where lambda is the linear charge density of the line charge or the wire. And now what we have is, we have an infinitely long cylinder cylindrical shell rather, with axis coinciding with the z axis. This is z, and let this be x. And here we have y. And in this situation, consider an element which is nothing but a wire, a long wire. So this is my element, which is infinitely long wire of thickness r d phi, where r is this radius of the thin cylindrical shell and phi is the angle taken from the x-axis. So if this is the angular location of the element, then this angle is phi. Now our surface charge density is given as sigma naught cos phi, which means that the charge is positive when phi is minus pi by 2 to plus pi by 2, and it is negative in the other half side. So it is positive here, negative here. As a result, the net electric field is along the negative x-axis. So the net electric field will be along negative x-axis. So electric field due to this element, we can first find out. So this would be d lambda over 2 pi epsilon naught r. Now d lambda would be sigma r d phi, that is surface charge density into thickness. And along the x direction, the component along the x direction will be dE cos phi. Remember that the electric field, resultant electric field, turns out to be along the x direction, negative x direction to be precise, because of the way this plus and minus sign is distributed. So the total electric field or magnitude of the total electric field would be by integrating in phi. Now cos squared phi is nothing but 1 plus cos 2 phi whole divided by 2. And this cos 2 phi integrates out to 0 in the entire period 0 to 2 pi. So we are left with just this half term, 1 by 2 term, and then integrated from the range 0 to 2 pi. So that gives us 2 pi over 2. So the answer is sigma naught over 2 epsilon naught. Option B. And just I would like to explain how I came up with this, that electric field is along the negative x direction. So let me just draw the xy cross section. So we have the xy cross section of the cylindrical shell, which is nothing but a circle, and this is my x-axis, this is my y-axis. And the charge distribution is cos phi, and phi is taken from the x-axis. So phi is taken like this. So we have positive charges lined up over here, and negative charges lined up in this half. And what we have is that if we look at some region, let's say over here, since cosine function is a symmetric function, if we look at this region, then symmetrically we have a region over here. Okay, so electric field due to this part would be like this, and electric field due to this part would be like this, and they would be equal in magnitude but in different directions. So since they are equal in magnitude, the resultant electric field would come out like this in the negative x direction. Similarly, for if we look in this negative half, so if we look at some part over here, then symmetrically we have another part over here, and due to this the electric field would be something like in this direction, and due to this it would be like in this direction, and again as a result you would have the resultant electric field along the negative x direction. So this is how I wrote this, that electric field is along the negative x axis. So this completes the question, and this completes today's session in which we looked at a few general aptitude questions, and the focus was on electromagnetic theory. And hope you learned some new things in this session, and that's all for today. If you have any more queries, you can post them in the Discord server that we have, and I will go through it and I will try to answer as many questions as possible, and even your friends can try and help you in the Discord server. So thank you very much.